Hi mathematicians. Today in this video we are going to talk about what it actually means when we are multiplying fractions. Now many of you may have learned that there is an algorithm or a way to multiply fractions to get what the product is of the two fractions. However, I want to make sure that you understand what the actual definition of fraction multiplication is. So we're going to go through this, and it's going to sound a little bit different, in fact very different from how you've probably been taught how to find what the product is for multiplying fractions, but we're going to get to what the definition is. Because definitions matter greatly, and having this definition of fraction multiplication will actually help you understand dividing fractions when you get to it. So this is really, really important. So let's get started. Some of you are probably looking at this and saying, whoa, Mr. Almeida, I'm not used to seeing symbols other than numbers in fractions. So I'm just going to tell you that this is a fraction right here in general. This is any fraction, and this fraction right here is any fraction. Both A, B, C, and D are all whole numbers. Okay? So just A, C, B, and D are whole numbers. But B and D cannot equal 0. Okay? Just know that. These two numbers cannot equal 0. So you could put any whole number here. This could be 5 and 4, so 5/4 times 9 twelfths. So you could put any whole number here. This is what we call the general case. So let's write that here. This is generally speaking for every fraction that is being multiplied by another fraction, this will be true. Okay? Here's what this means. The definition of this fraction multiplication is the total of A parts when the length from 0 to C deths is partitioned into B equal parts. Okay? So when you see this right here, you read it as this. The total of this many number of parts when the length from 0 to this fraction right here, this number, is partitioned into this many number of equal parts. So I've color-coded them so you can see where the numbers are coming from. And every single time that we see fraction multiplication, we can write out a full definition in these words right here. So it's always going to be the total of this many number of parts when the length from 0 to C deths is partitioned into this many number of equal parts, which in this case is B. Okay? But you could use any symbol here. Just know that A, B, C, and D are whole numbers. All right. Let's go to a specific case, because I think that this general definition might be a little confusing until you see it actually in play with some specific numbers. So as you can see here, I don't have the A bths times C deths. I've actually told you what the whole number A, B, C, and D are. So this fraction is 3/4 times 5/7. Anytime you get specific numbers, we call this a specific case of the definition of fraction multiplication. So to use what we learned before, this fraction multiplication is defined as what? The total of 3 parts, it's always the numerator of the first fraction, when the length from 0 to the entire second fraction, 5/7, is partitioned into 4 equal parts. And partitioned means broken equally into. Okay? So let's actually show this on the number line. If you want some information as to what the meaning of a fraction is, you can watch a video. I'll post the link right here for you to click on. And let's continue. So what we're always going to do is we're always going to model this fraction first. Okay? So we're going to model the length from 0 to 5/7 first. We're going to model our unit first. So the length from 0 to 1, our unit. We're now going to partition this unit into 7 equal parts. I'll partition it into 7 equal parts, and then I'll go to the 5th point to the right of 0. The first, that's 1/7, 2, 3rd, 4th, 5th point to the right of 0. In the sequence of sevenths is 5/7 here. So now what I'm going to do is I'm going to take this length right here. Let me color code it so you can see it. I'm going to take the length from 0 to 5/7, and I'm going to partition that into 4 equal parts. Now, how many parts do you see here? 1, 2, 3, 4, 5. 5 is not divisible by 4, but what I can do is I can make 5 divisible by 4 by partitioning each of these 5 parts into 4 equal pieces. So I'm going to do that to each of them. Partition each of the 5 equal parts into 4 equal pieces. But because these pieces are being partitioned into 4 equal parts, I'm also going to do that to all of them. So let's do that. 4 equal parts, 4 equal parts, 4 equal parts. From here to here is partitioned into 4 equal parts. This segment right here partitioned into 4 equal parts. This segment partitioned into 4 equal parts. And this segment partitioned into 4 equal parts. Okay, now that I've done that, I now want to figure out how many of these smaller pieces are from the length 0 to 5/7. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 smaller pieces divided into 4 equal parts, or broken into 4 equal parts. We would do 20 divided by 4, which is 5. That means that each of these parts is going to be made of groups of 5. So let me highlight in a different color. Every 5 of these smaller pieces is going to be a part. So 1, 2, 3, 4, 5. That's one part. 1, 2, 3, 4, 5. That's another part. 1, 2, 3, 4, 5. Yes. Let's do another one. 1, 2, 3, 4, 5. That's another part. And then 1, 2, 3, 4, 5. That's another part. So I've partitioned it into 4 equal parts. So I've taken care of that. Now the last step is to come here and see how many of these 4 equal parts do I need to take. And I want to take 3 of them. So I'm going to take 3 of those parts. That would take me from here all the way. Those are 2 parts, 3 parts, right here. And right here is where 3/4 of 5/7 would be located, or 3/4 times 5/7. Okay, let's actually figure out what the name of this point on the number line is. We are going to look at the unit and see how many pieces it's been broken up into, and that's going to name our denominator. How many equal parts are there from 0 to the unit? So we count these individually, 1, 2, 3, 4, or we could know that every one of these bigger tick marks is a group of 4. So let's start counting. 4, 8, 12, 16, 20, 24, 28. So this is the sequence of 28ths. So I label that there. And now I want to figure out what point to the right of 0 am I? So let's start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the 15th point to the right of 0 in the sequence of 28ths. And that's what fraction multiplication is. So when you see this, two fractions being multiplied, it actually has a definition where you're going to take a certain number of parts when this length is partitioned into this many number of equal parts. We're going to have one more example, and let me see if you can figure out what goes in these blanks. So I'll pause. You can pause the video and see if you can predict what is going to go inside of these blanks. Alright, now that you've taken some time to figure that out, this specific case of 2/3 times 9/10 is going to be defined as the total of two parts when the length from 0 to 9/10 is partitioned into 3 equal parts. Okay, let's model this on the number line so we can see what point we actually get to. Okay, we're going to always draw our unit because this is really 2/3 of 9/10 of a unit. So we're going to partition our unit into 10 equal parts. So we've partitioned this into 10 equal parts, and we're going to go to the 9th point to the right of 0. So start at 0, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th point to the right of 0. That's where 9/10 is located on the number line. Okay, now we're going to take the length from 0 to 9/10. This length right here, from 0 to 9/10, and we're going to partition it into 3 equal parts. Well, how many parts are there between 0 and 9/10? Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 parts. Can I divide 9 by 3? Oh, yes, I can. So therefore, 9 divided by 3 is going to be 3. That means every group that I make now, every part that I make, is going to be made up of 3 of these smaller pieces. Okay? So no need to partition each of these pieces because the number of pieces I have is already divisible by 3. So 9 divided by 3 is 3. So my groups are going to be of size 3. Let's show that. My groups are of size 3. So there's 1, 2, 3. That's one group. That's one part. 1, 2, 3. That's another part. And then 1, 2, 3. That's another part. How many of these parts am I going to take? I'm going to take 2 of them. So the length from here to there is 2 parts. And this point right here on the number line is where 2/3 of 9/10 will be located. What is this point exactly? It is the 1st, 2nd, 3rd, 4th, 5th, 6th point to the right of 0. And when you use the equal sign does not mean this is my answer. The equal sign means is the same point on the number line as. Is the same point on the number line as. Okay? And then in the sequence of what now? Let's see. In the sequence of 1, 2, 3, 4, 5, 6, 7, 8, 9, tenths. So this point on the number line is 6/10. Okay? And that is how you define fraction multiplication. All right? Please come back to Math with Mr. Almeida to figure out some more math ideas. I look forward to seeing you in some other videos. Take care, everybody.